Guys, what is H1? Guys? Hello? Can you hear me, guys?
Yes, Doctor.
Yes, doctor.
Have you got your H1? Yesterday we have a look at the pit water heater open type, and given right here is the P1 T1, and then we can have the H1 at 10 megapascal, 600 degrees C. So we'll be getting the H1.
So H1 is 3625.8.
Okay. So our H1 is equal to 3625. 3625.8 kilojoule over kilogram. And we need our S1 because S2 is equal to S1. And then the S1 is 6.9045. Okay, thank you. And then for state 2, we are going to have the pressure is at 0.6 and the S2. So based on 0.6 megapascal S2, then we are going to get our H2. Okay, I think most probably you are going to look at you are going to use the interpolation. Okay, and we have proven that yesterday the state of 2 is at superheated vapor. So based on P2 and S2 is equal to S1, okay, at superheated vapor, and by interpolation, you are going to have your H2. Anybody have done that? Anyone? Buat lagi. Okay. Do it now, please. Based on P2, your P2 is equal to 0.6 megapascal. So if we look at, guys, please follow me buat jangan tak buat tau. You tak buat, apa you dapat? Cakap salin aja, tak boleh lah macam tu Please do it. So let me open the table for water. Table for water, appendix, water. All right. So table for water. Point 6. Superheated vapor. 6.6 superheated vapor. And then we have our S is a 6.9045, 9.045. So the S2 is 6.9045. Where is 9045.6? Yeah, here we are. In between this and this. Okay, in between these two sets. 0.6, 6.9045. 6.9045. Yeah, this one. This and this set. So you have to interpolate between this. So this will give you the H2. Okay, try to interpolate it. At 0.6. Then you add your S, then we need the H2. So this is where you need to interpolate. 0.6. Oh, sorry, it's 6.0. Alamak. Sorry, not this one. 6.9045. 6.9045, this one. This set. And this set. We need the enthalpy. So the enthalpy is right here. Okay, try to interpolate that.
2821.
2821.
0.78.
0.8. Okay.
0.78.
Okay, 0.8 saya ambil satu decimal point. Okay. So next will be the H3. Okay, so to get the H3, then we get the P3. P3 is equal to 0.2 megapascal. So this is 0.2 megapascal. And the S3 is equal to S1. The same value right here is 6.9045. 6.9045. And we found that this is at mixture. Okay, mixture. Therefore, how to get the H3? H3 is equal to HF3 plus X3 HFG3. And before that, we need to get our X3 is equal to S3 minus SF3 divided by SFG3. Okay, get the X value first. Okay, anyone?
Zero point 0.9602.
0.9602. So this is 0.9602. So put that x into this formula. What you get your H3?
Two six one 2618.79.
2618.79.
79.
So it's 8, correct? Kilojoule over kilogram. Then we are using the P4. P4 is equal to 5 kilopascal. And S4 is equal to S1 again, 6.9045. So based on this, we are going to have mixture. Then therefore, we need to get the X4, which is equal to S4 minus SF4 divided by SFG4. So get your X value. Then after we got the X value, then we use this formula. H4 is equal to HF4 plus X4 HFG4. Then we will get the value of H4. So get your X4 first.
Sir, I got X4 value 0.8119.
0.8119. Okay, then.
Did anyone else get the same answer?
Yeah, same value.
Okay, thank you. And then try to get your H4.
I got 2104.
2104.
0.98.
0.98. Oh, that means 9805 lah.
Yeah, that's true, sir.
05.0 kilojoule over kilogram. Okay, so after X4, we are going to get what? 5, right? So we have solved the 4. Now we go next is 5 here. H5. What is H5? H5 is
at 5
equal
kPa.
to HF at 5 kPa, straight from the table.
137.75.
137.75.
Yes, doctor.
Okay. The next is H6. H6 is equal to H5 plus 0.001. Your P is what? P, the next P is 0.2, correct? The pressure involved right here is
P6 minus P5.
0.2. 200 minus 5. This is P6 minus P5 equal to
137.95.
137.95. 137.95 kilojoule
Yeah, man,
over kilogram. Okay? After H6 is H7. So what is H7? H7 is HF at what is our pressure?
0.2.
0.2. This is 0.2.
200 kPa.
Yeah, 200 kPa. Same thing. Equal to
504.71 kilojoule per kg.
504, right? 0.71.
Yeah.
Okay, kilojoule over kilogram. Then we need to get the H8. H7, no H8. What is H8? H8 is equal to H7 plus 0.001 P8 minus P7.
So P8 is 600 kPa, right?
Or wait, P8. I don't remember the pressure. See, this is the pressure. P8. Sorry. P8 minus P7. P8 is at 0.600 megapascal.
Okay.
Sorry, 600 kilopascal minus 200 kilopascal.
I got 505.11.
505.11. 505.11.
Anyone else?
Anyone can verify that?
I got the same answer. Yes.
Yeah,
Same
Rohan?
value.
Same value. Okay, thank you very much. Then that is for H8. Now H9. What is H9? Sorry, H9. H9 is HF at 600 kilopascal.
670.38.
7? Sorry.
670.38.
Again?
670.38
Okay. 670.38.
kilojoule per kg.
Yeah. Then we have the H10, the last one, is equal to H9 plus 0.001. This is a P. Which P? The highest P is our boiler P, which is our
P10.
P10 minus P9. The P10 is 10,000 kPa. P9 is 600 kPa.
I got 679.78, Doctor.
679.
0.78.
Okay, that means 680.0. 680.0, correct?
Correct, Doctor.
Doctor, how many decimal place are we to put for enthalpy?
For enthalpy, if you, in this case, right, this you get from table. The 670.38 is from table, so you leave it as what it is. But for the others, I should just put around maybe okay lah, we can put 2 decimal point or 1 decimal point, but it's all depend on the values, right? So big, I think just put 1 decimal point is okay. So what is your
for H10? I got if we are to put 1 decimal place, the answer should be 679.8.
Oh, okay, 679.8.
0.8.
Okay, thank you. Okay, meaning that now we have solved all the value, correct? Or the enthalpy. Now what are we going to do?
Find Y1, sir.
Find Y1. Okay. So how do we solve for Y1?
Energy input, energy out.
Energy balance. For which water heater?
One.
First one. So put in the value, get your Y1. H2, you have H2, H8, and H9. So get your Y1.
Sir, I got 0.0754.
0.0
754.
0.0, right?
Yeah, correct.
754. Okay, next, get your Y2.
But just to confirm, did anyone get the same answer too?
Okay, can someone?
Yeah, 0.04, 0.07. Yeah, same answer.
Okay, 754.
Thank you.
Okay, now get your Y2. Using this formula, get your Y2. Anyone? Daniel, kau nak masuk Daniel? Daniel?
Oh, doktor.
Boleh masuk ke? Okay, anyone? Y2?
Sir, I got 0.0178.
0.0? Are you sure?
078.
0.1. 0.1373.
That should be better. Iwa, can you calculate again?
Okay, sir, I'll recheck.
Check back, because it's too small. Because if you put 0.0, meaning that you're not getting 1 again after this. Very small. Okay, assuming that this value, maybe someone can, anyone confirm this value of y2, 0.1373? And also the y1, anyone? Can we confirm back these values? Y1 and y2. Alip, okay tak Alip? Y1 or Alip?
Y1 okay?
Okay. Asana, Y2 okay? Afaf, Afaf, Sana, Jadatul, Sinar. Ramai student kat sini.
Yes, doctor.
Okey tak nilai-nilai tu?
Okay, sama.
Sama Okay, thank you. So, is everything is okay? No, now we are trying to get what is W net. Okay, I'm not going to answer the question first, but I'm going to solve one by one what might be asked from the question. Okay, so after getting all the y values and the enthalpies for every state, let me sketch it back our TS diagram so that we have have a very clear picture of that. So this is our TS diagram. Okay, remember this is our expansion process, and we have 2 point which is at saturated mixture. Okay, this is saturated, and this is superheated, this is superheated. This is 0.1, 0.2, 0.3, and 0.4. Okay. This is the 3 expansion process in the turbine with different fraction. Okay, with different fraction. Okay, remember what is flowing from the boiler? The flowing from the boiler, remember what is the flow rate? I think it's 22 kilogram. It's not mistaken, it's
Yes,
from the
doctor.
question. 22 kan?
Yes.
22, sorry. That. It's not mistaken, it's 22. Where is it? Yeah. This is the flow rate. 22 kilogram per second. So what is flowing right here is m dot, which is m dot is equal to 22 kilogram per second. Okay. Here also m dot. Now we have extract. This is y1. From here we extracted y2. And right here, what is left is 1 minus y1 minus y2. Okay? And this is our boiler. Oh, pressure involved. Four, this is 5, 6, 7, 8, 9, and 10. So what is our W net? The W net, right, is equal to the W12 plus W23 plus W34 minus W56 minus W78 minus W910. So we have to define each one of them. If you want to put everything inside, okay, no problem. If you want to put all the enthalpy, so this is your W net. You want to define one by one, or you want to define everything in one equation? What do you think?
Better separate first. Doctor.
Okay, we separate it. Okay. So what is W12? W12 is equal to the mass flow rate, the fraction is 1, H1 minus H2. Okay, get that. After that, W34 is equal to 1 minus Y1 H3 minus H4. Get that. Okay. Remember, we have extracted Y1. So what left here is, sorry, it's not, is Y1. This is 1 minus Y1. And then oh, I got it wrong. Sorry guys, let me rewrite that because I left 2, 3. Okay, I left the 2, 3. So this is equal to, and then we are going to get, this is a Y23, 1 minus Y1, H2 minus H3. 3. And then W34 is equal to 1 minus Y1 minus Y2 H3 minus H4. Can you guys get for me what is the W12, W23, and W34? Take note that what is flowing at this 2 to 3 is 1 minus Y1. What is flowing right here is 1 minus Y1 minus Y2. Okay, W12.
Dapat 203 sir. 203 kilojoule per kg.
Point
Point tadi sir.
0.
Yeah.
2, 3.
Sorry sir, tadi yang W122 804.01.
804.
4.01.
804.
804.01.
0.01. Okay, thank you. Can someone verify that?
Yes, same value.
Okay, good. Now W23.
Sir, I got 187.7.
187.7
7.
kilojoule over kilogram. And the last part is for W34.
404.5.
404.5 kilojoule over kilogram. The next, we are going to calculate the pump work, the pumping work. So the the W56 equal to 1 minus y1 minus y2 h6 minus h5. And then our W78 is equal to, now this is 1 minus y, 1 minus y2. And then at 0.7, we are combining the y2. So what is left is 1 minus y1. 1 minus y1 h8 minus h7. The last one is W910, which is equal to h10 minus h9. And the fraction is 1. Because we have combined at 9, we have combined y1. So y minus y1 plus y1 is equal to 1. Okay.
So I got 0.1575.
0.1575.
Memang the value is small lah. So
Macam mana?
the value memang 0.1 something, is it?
Yeah,
Usually.
it's very small.
Oh, okay.
Yang kita dah buat sebelum ni pun kita dapat 3 ataupun 4 aja. This is lagi kecil lah because the pressure ratio is smaller.
Okay, sir. Thank you.
Okay, 7, 8.
Doctor, I got 0.3698.
Okay, and the last one.
I got 9.42 kilojoule per kg, sir.
Which one?
The W910.
Okay, what is that? 9 point?
9.42 kilojoule per kg.
Or 2? Give me another 2 because we are using, this one is small, so we take all decimal point.
0, 0, sir.
0, sir.
All right. So after getting all the turbine work and also the pump work, now you use this formula, get our W net. Yeah.
1386.26.
1386. Okay, very good. Okay, we have already get the W net. What do you think that we should find in the next parameter? What do you think? What you want to know?
SSC, sir.
How come SSC first? You want to know how good is your plant. So what determine how good is your plant?
Efficiency.
Efficiency, sir.
Yes, our thermal efficiency, which is equal to the W net divided by the Q in. This is the amount of work that we are getting from this plant in terms of kilojoule per kilogram. Now we want to look the efficiency, the quality of our plant. And this should be the Q in is equal to H1 minus which H? H1 minus
H10.
H10. Are you sure? H10. Why H10? Why H10? How about the 6? How about the 8? Why 10? Okay, the increment of temperature from 5 to 6, 6 to 7, 8 to 9 is from the feed water heater. Okay, it's not from the boiler. It's not from the Q in. Remember, 6, 7 is the second feed water heater. The increment of temperature 8 to 9 is basically based on the feed water heater number 1. But what we are going, the energy input in terms of heat is only from 10 to 1 at the boiler side and also at the superheater side. Therefore, the Q in is equal to H1 minus 10. And what is the fraction of flow rate right here? The fraction of flow rate is 1. Okay, it's 1. So can you get your Q in?
Sir, I got 2946.01 kilojoule per kg, sir.
2946.01
01. Yeah.
kilojoule over kilogram. Therefore, what is your thermal efficiency?
Forty-seven point zero six.
47.06 kilojoule over kilogram. Sorry,
Percent.
percentage. Oh, very good, eh? This one very good. Nice value. We get very high efficiency. That is why we use two type. 2 unit of feed water heater. Okay. Next, what do you think that we could get? This is based, okay, this thermal efficiency is based on the W net in terms of kilojoule for every kilogram of steam. So the next parameter that we should look is always in terms of the power output. Okay, power output. And the power output is equal to the M dot multiplied by the W net. Okay, you just multiply the W net with M dot. The M dot is, in this case, the M dot is given as 22 kilogram per second. And then the next one is the SSC. Get your SSC, which is equal to 3600 divided by the W net. Or you can use also your 3600 multiplied by your M dot divided by your W dot net. You will get the same figure, your SSC. Okay, so you proceed with that. And then the next thing that we could have is the amount of flow rate for every each component. Okay, so the interest is to get the mass flow rate for each component. The first component, the m dot that we could have, this is the m dot for the boiler. So how much is the m dot for the boiler? How much is the m dot for the boiler? In this case, this is
22.
equal to m dot, right? It's equal to m dot, which is equal to 22 kilogram per second. The next one is, we want to know how much is the flow rate being bled or being extracted to the first feed water heater. Right? This is equal to the m dot multiplied by 1 minus, this is equal to m multiplied by y1. Then we have our flow rate to the first feed water heater. And then we might ask for the flow rate of the feed water heater number 2, which is equal to m dot multiplied by y2. And then we might be asked for the m dot for the condenser. And this is equal to m dot 1 minus y1 minus y2. So this is the possibility that we should know, or we will be asked to get the individual component mass flow rate. Okay, so we might be asking for the mass of the boiler, which is equal to the mass flowing into the total mass flowing through the cycle. And then we might have how much is the bled steam for each feed water heater. In our case, we have 2 feed water heater, number 1 and number 2. And then the last one is get the mass flow rate flowing through the condenser, which is equal to m dot 1 minus y1 minus y2. Okay, that's why I don't like, or I do not advise you to get the y value in terms of kilogram. Just put it as a fraction of flow, fraction of every 1 kilogram of flow. And then if the question given the mass flow rate, then we could get the individual flow rate for each component. Right? So this is the possibility or the values that you can be asked and to evaluate for a steam power plant. Okay. Any question? Any question, guys? Okay. Kalau tak ada, next we are going to
Sir,
look.